really much in this chapter which you guys don't know already. So it's just going to be a matter of revision. And we'll start X-rays maybe in the next class. Let's hopefully finish Bohr's atomic model today. But yeah, it's just a revision of whatever I think you've already done in chemistry. तुम इसमें HCV कर लोगे. HCV has a good collection of questions. It'll be more than enough. I think, in fact, I think it has more than enough questions for this small topic. The best part about this topic is it's purely conceptual. Okay, so in fact, the entire topic can be summarized with these two fundamental equations. So everything comes down to just these two equations. First one is as an electron moves around the atom, your electrical force is equal to your centrifugal force, right? So Kz E square by R square is equal to mv square by R. And the other equation is your Bohr's quantization rule, that MBR is NH by 2 pi. So now we are going to start the numerical part of this chapter. I think till page 7, there was a lot of this discussion on theory and the history of atomic models. But now we're going to work with these two important equations and find certain other things. Now, if I remember correctly, I think मैंने तुम्हें last class में ही ये सब attempt करने को बोला था, right? Done that? I don't know if you guys left by then, but do you guys get to? Okay, I think you guys got to attempt this question. So the question was, given atomic number and given the orbit number, okay, you should be able to find yes, Prithvi, yes. हाँ, मतलब कोई बोल रहा है अगर रिवाइज करने का टाइम कम है तो कैन बी स्किप द हिस्ट्री पार्ट, ऑफ कोर्स. मतलब बट इसमें लाइक हिस्ट्री पार्ट में यू कैन स्किप लाइक द फर्स्ट पेज एंड ऑल, जस्ट क्विकली रश टू द पोस्टुलेट्स वंस, क्योंकि कभी कभी थियोरेटिकल सवाल ऐसा आता है एमसीक्यूज में, लाइक this is what Bohr said, or this is what Rutherford said, or this was the problem with them, right? Especially don't skip Rutherford's model, because that's mentioned in your syllabus, in your main syllabus. And if it's mentioned, I mean, it's just the usse bas theoretical sawal aa sakta hai. There's no numerical that we'll be practicing on, or we can practice on the Rutherford's experiment. So just read it once, read the postulates of Rutherford and Bohr. You don't need to memorize anything, you just have to understand. Okay, this was what they said. This was probably not very accurate. This was good. Okay, so just you'll go through it quickly. But now this is the main stuff, especially from an advanced perspective. This is the main stuff. Okay. Oh, very nice. Good. So some of you were able to solve for almost all the parts except magnetic field at the center. Okay, fine. Fair enough. Let's go through these parts. Okay. So in fact, isme the first 5, deriving a formula for the first 5 in terms of Z and N. So the first 5, that's quite important. Okay, these are a little bit more common than the others. Okay, but of course, advanced can really ask anything. But yeah, and you've done it all in chemistry. Excellent. So jaldi se dekhte hain. So radius ka formula. So using the first equation, the fact that electrostatic force Kz E square by R square, nucleus ka charge Ze, electron ka charge E. All right. So, but we'll come to that. Okay? We'll come to that. So Kz E square by R square, electrostatic force is the centrifugal force. Okay. अब यहाँ पे मैं क्या करूँगा? I think I can. Yeah. So I want to write this entire thing now. I just want I want R in terms of all constants. Okay. So in fact, everything over here, Kz E square NH by 2 pi, they're all constants except M, except V, except velocity. M itself is mass of the electron. That's also constant. V is not a constant. तो उसके लिए मैंने बस क्या किया कि या तो तुम v सब्स्टिट्यूट कर लो या mv स्क्वायर को तुम लिख सकते हो mv द होल स्क्वायर डिवाइडेड बाय मास, मतलब मोमेंटम का स्क्वायर बाय मास, and then that allows me to use this equation mdr is nh by 2 pi and md को मैं nh by 2 pi r से रिप्लेस कर सकता हूँ। तो ये यहाँ पे जो md का स्क्वायर है, ठीक है, एवरीथिंग एल्स केप्ट द सेम, md का स्क्वायर को मैं nh by 2 pi r का स्क्वायर से रिप्लेस कर रहा हूँ। तो nh का स्क्वायर by 2 pi r का स्क्वायर which will be 4 pi square r square, ठीक है। Now on doing that, r square gets cancelled out and we get a value for r. So take r over to the left hand side and the value you get is n square h square by 4 pi square e square z km. Okay, you get this particular value, and I'm sure you guys were also, I mean, whichever way you did it, you probably would have landed on this value. Okay. Should we remember this result? My answer is obviously you don't need to remember this result. You can always derive this result. It hardly takes time. Make sure you are you have a clear pathway in your head to quickly derive the result if you need to. Right? So make sure you can derive it quickly. Practicing to derive it a couple of times will be more beneficial than remembering this result. What you should, however, remember is keeping these constants aside. Okay, these are all constants. M is mass of the electron. The proportionality, very nice. So you should remember that radius of the orbit is proportional to n square by z. So n is the orbit number. Okay, so first orbit, second orbit, third orbit, electron jape hoga. Select single electron system hai ye. Okay, the radius of a particular orbit is proportional to the orbit ka number ka square divided by the atomic number of the central atom. So as you might have seen, your central atom, so that your basic atom could either be hydrogen or it could be He plus, or it could be Li2 plus or beryllium 3 plus. Even if they are imaginary, even if you can't imagine an Li2 plus or a helium plus, that's fine. The whole point is there will be enough plus charge on the atom to ensure that there's only one electron. So Bohr's atomic model in that sense will be valid. And what they'll basically be doing with that is they'll just be creating a question where the atomic number also can be tested or can be used. For helium 2, lithium 3, beryllium 4, and so on. So remember the proportionality. Radius is proportional to n square by z. Moreover, also remember key in the first shell of the hydrogen atom, okay, when n is 1 and z is 1, the remaining terms, okay, okay, very nice. So koi bol raha hai this, acha, okay. Somebody is saying you can remember this using the word runners. Runners, RUNNERZ, runners. क्योंकि runners में 2 n है और ending में s के जगह z बोल सकते हो. तो in that sense, there are 2 n's and 1 z. Okay, fair enough. ठीक है? Yeah, whichever way you remember it, it is not mine. Credits to, who was that? Ayush. Okay, but yeah. So whichever way you remember, please remember it, and also remember the value of this. So all of these constants, when you plug in their values, okay, you can check in your own time. I've checked it once. So they come out to be close to 0.53 angstrom. Okay, so that's important to remember. So just remember one reference value. This is the value of the radius when n is 1 and z is 1. So this is the radius of the first orbit of a hydrogen atom. Okay, so if you remember 0.53 angstrom and you remember n square by z, then if I ask you the radius of the third orbit of lithium atom, Li2 plus atom, in fact, then you'll be able to do that easily. So that'll be 0.53 into 3 square divided by atomic number of lithium, which will be again 3. So you can, if you remember the first one, you can get everything else with the proportionality. All right. So I'm sure you remember that first orbit of hydrogen ka radius is 0.53 angstrom. All right. So that's the first question solved. Any doubt on this? None. Okay. The next one, next वाले में velocity निकालना है, ठीक है? V in terms of all the other constants. So that means V not in terms of R. Okay, V should only be in terms of constants because R itself is a variable. So kz e square by r square is equal to mv square by r. वो Newton's second law है basically. R काट दो, तो दोनों side R काट के I'm going to take R to the right hand side. That makes my equation kz e square is mv square into R. But वो mv square into R को मैं लिख रहा हूँ as mvr into V, right? mvr into V. mvr is nh by 2 pi. So this is nh by 2 pi into V, and that makes the velocity of the electron in the nth orbit equal to kz e square into 2 pi by nh. Okay, so whichever way you derive it, just make sure you can derive it quickly. And if you can derive it quickly, you do not need to remember this particular result. Again, what you should remember is the proportionality. So there is no magnetic force on the orbit. No, there's no magnetic force on the orbiting electron. वो इलेक्ट्रॉन खुद मैग्नेटिक फील्ड क्रिएट कर रहा है, खुद पे फोर्स नहीं लगा रहा है. ओके, तो फिर velocity is directly proportional to हाँ, the proportionality is important, directly proportional to z and n. Variables से कैसे related है वो याद कर लो. Z and n are the variables which vary with the atom and the orbit. So V is directly proportional to Z by n. बाकी सब universal constants है. When you plug in their values, you get roughly 2.2 into 10 to the power 6 meters per second. It will be useful to remember that 2.2 into 10 to the power 6 meters per second. That was the velocity of an electron in the first orbit of your hydrogen atom. And first orbit is, I'm sure you know, it's called as the ground state of your hydrogen atom. So an electron in the ground state of a hydrogen atom, according to Bohr's, has a velocity of 2.2 into 10 to the power 6 meters per second. And if you want it in any other atom, in any other orbit, then accordingly you have to place the values of Z and N. So this is another important result to be remembered. Any doubts in this one? Okay. है तो please पूछो. Next is energy. Okay. All right. Great. So energy, kinetic energy is going to be half. Great. Kinetic energy is going to be half mv square. Okay. So simple, just half m. पिछले page का answer का square. Okay. So to save you the trouble, when we do that, ठीक है, तो पिछले पेज में z by n था तो उसका स्क्वायर हो गया. फिर पिछले पेज में ऊपर था 2 पाई के ई स्क्वायर, उसका स्क्वायर लोगे तो आएगा 4 पाई स्क्वायर के स्क्वायर ई रेज टू 4. 4 का 2 हो गया बिकॉज ऑफ दिस हाफ आउटसाइड, एंड डिनोमिनेटर में था h, तो यहाँ पे h का स्क्वायर हो गया. तो बेसिकली वंस यू गेट वेलोसिटी यू कैन गेट द फॉर्मूला फॉर काइनेटिक एनर्जी एज वेल. Again, no need to remember this, but remember a pathway to the answer. Okay. Kinetic energy is also proportional to, yes, Prithviraj, yes, we'll come to that important relation. So kinetic energy is proportional to z square by n square. Okay, that proportionality is important. And when z and n are 1, its value is 13.6 electron volts. So kinetic energy is 13.6 z square by n square electron volts. And kinetic energy is always positive. Again, nothing new over there. That's our result. Okay. But let's see what potential energy is. The potential energy is K Q1 Q2 by R. So it's going to be K charge of the nucleus upon charge of the into charge of the electron divided by R. So because electron का charge negative है, this entire term becomes negative. और R का value अगर substitute करोगे तो न्यूमरेटर माइनस के जेड ई स्क्वायर हो गया, बट R का वैल्यू डालोगे जो हमने पहले डिराइव किया n स्क्वायर h स्क्वायर बाय z 4 पाई स्क्वायर e स्क्वायर के m, वो डालने पे और इसको सिंप्लीफाई करने पे जब जो रिजल्ट आएगा दैट्स गोना बी माइनस z स्क्वायर 4 पाई स्क्वायर m k स्क्वायर e टू द पावर 4 अपॉन n स्क्वायर h स्क्वायर. Okay, so this is, if you look carefully, वहां पे 2, look at that, 2 pi square m k square e raised to 4 by h square, 4 pi square m k square e raised to 4 by h square with a minus sign. बाकी z square by n square ऊपर नीचे दोनों है. So the potential energy term is almost the same as the kinetic energy term. The only thing is it has a minus sign and it has an extra 2 multiplied with it. तो पोटेंशियल एनर्जी में 4 पाई स्क्वायर था और काइनेटिक एनर्जी में 2 पाई स्क्वायर था. तो पोटेंशियल एनर्जी इज -2 टाइम्स द काइनेटिक एनर्जी. तो जो भी काइनेटिक एनर्जी है पोटेंशियल एनर्जी इज -2 टाइम्स दैट. सो -2 into 13.6 z square by n square electron volts. Is it okay if we just remember all the are you saying is it okay if you're saying is it okay if we remember these results? ये पूछ रहा है क्या? As questions in chem are based on that only. Not just in chem, even physics, the questions are based on this only. If you're asking me whether you want to remember the exact results, if you can and you want to, go ahead. I personally feel sometimes when we remember big results, even if we remember it correctly in the exam, वो एग्जाम में थोड़ा सा डाउट आता है, am I remembering it correctly? ये e raised to 4 है या k raised to 4 है? So sometimes ऐसा मतलब you want, you can remember it provided you actually do remember it, and provided in the exam you don't have any, you don't hesitate, you don't get confused, you don't doubt whether you're remembering it correctly. Because if you're going to do any of that, I would say derive. It hardly takes time to derive. Hardly takes any time to derive. And even if you're going to remember the result, practice the derivations. Because तुम तो याद first 5 कर लोगे, जो total energy तक पूछा है वो याद कर लोगे, because उस पे सवाल बनता है normally, है ना? You would not memorize the other results. That's pointless. Magnetic field and angular velocity and all, you wouldn't remember that. So there can be some things that your advanced exam may ask, which you may have to derive. So in general, practice the derivation. हर बार revise करते वक्त, even if you remember the result, do practice deriving the result. Okay, potential energies, and that's all this chapter is about. That's all this chapter is really about. Okay. If you memorize in chem, then very nice. Good. Chalo, superb. ये ऐसे results में memorize कर ही लिया, then ठीक है, good for you. और जिन्होंने नहीं किया, it's not a big deal, derive कर सकते हो, ठीक है? But at least proportionality याद कर लो. हाँ, yes शिवांक, yes, I'll talk about that. तो इसमें क्या है ना, like जैसे एडवांस में एक सेकंड, I'll come to that. So just to wrap this up, potential energy is -2 into Shivang, what you said, I'll come to that in a little later. Okay, I have questions like that, so we'll see them. Potential energy is -2 into 13.6 z square by n square electron volt. Remember that it's proportional to z square by n square. वो याद करना है at least. And the trick is you remember velocity is proportional to z by n. So automatically kinetic energy is proportional to z square by n square, because kinetic energy is proportional to velocity का square. And जो जैसा kinetic energy है उसी nature का potential energy और total energy है. Their formulas are similar, only there is a factor, a constant in between them. So when you go to find your total energy, this is the very important one. Total potential energy was minus 2 times kinetic energy. Total energy is the sum of potential plus kinetic energy. So mine potential is minus 2 ke. So minus 2 ke plus ke becomes minus ke. So your total energy is just the negative of your kinetic energy. Okay, total energy is just the negative of your kinetic energy. तो जो भी kinetic energy का result था उसी का negative है तुम्हारा total energy minus 13.6 z square by n square electron volt is your total energy. Okay, now again remember that is proportional to z square by n square. So in hindsight, this by the way is the most important result. This result tells you that the energy of an atom where the electron is in the first orbit, and that too the atom is a hydrogen atom. So उस system का energy when Z is 1 and N is 1 is minus 13.6 electron volt. Okay, so that value is very, very important. It's this value which ultimately determines कि जब electron एक orbit से दूसरे orbit में जाएगा तो जो photon वो release करेगा या absorb करेगा उस photon का wavelength क्या होगा ये formula determine करता है. So this formula is very important. Total energy वाला. And if you ever find the need to figure out what kinetic energy is or what potential energy is, use this result. The fact that total energy का negative is kinetic energy. तो total energy kinetic energy का negative है और potential energy का आधा है. Total energy kinetic energy का negative है और potential energy का आधा है. Okay, so that's an important relation. In fact, this is the relation for any orbiting system. It's also true for your Earth Moon system. I'm sure you guys might remember that. The Earth Moon system may be as a relation दिखेगा. Okay. Similarly, binding energy, again similar to your Earth satellite system. Binding energy is the energy needed to remove the electron. Okay, binding energy of the atom is the energy needed to remove the electron. Okay, this may also be sometimes called as the ionization energy. So is the energy required to remove the electron. So binding energy is going to be negative of your total energy. Why is it negative of your total energy? I hope you know the reason. है ना? Because तुम्हें binding energy मतलब तुम्हें ultimately 0 electron volt पे पहुंचना है और तुम्हारा यहाँ पे total energy का value इतना है. So to infinity पे 0 है. Okay, that's the convention. If the electron is far away from the atom मतलब it's at a very, very large orbit, वैसा imagine कर सकते हो. So if it's at a very, very large orbit, if n tends to infinity, the entire total energy tends to 0, right? So that's the convention. If the electron is removed from the atom, the energy is 0. ये वो convention है. और एक particular orbit में उसका energy TE है, total energy TE है. The binding energy is the amount of energy you need to give for this jump. So the energy you need to give for this jump is final energy minus initial. Final has 0, initial at TE. So the energy increase is 0 minus TE. तो इतने से एनर्जी बढ़ेगा, माइनस TE से एनर्जी बढ़ेगा. मतलब इतना एनर्जी तुम्हें देना है to remove that electron. माइनस TE के बराबर एनर्जी देना है to remove the electron. Okay? And TE could negative है, that's why it may sound a little weird. TE could negative है, तो minus TE positive है. तो इतना एनर्जी तुम्हें देना है to remove an electron from the atom. Okay? It can be called as binding energy of the atom, or it can be called as ionization energy. Any doubts so far? which is right off the atom. Because later when we study the nucleus, there is another concept called as binding energy of the nucleus. Yeah, that's for the next chapter, radioactivity. So I'm just being a little bit more specific. And यहाँ पे correct me if I'm wrong, chemistry के perspective से इसको ionization energy भी बोल सकते हैं, है ना? Okay, great. Ionization energy. The energy required to further remove an electron is ionization energy. Okay. Ionization enthalpy, is it? I doubt. I think it's energy. Yeah, it's energy. Cool. Enthalpy थोड़ा cross check कर लो. It's been a while. I think enthalpy has a, if I'm not wrong, it has a per mole aspect to it or something like that. But it's not enthalpy. Just a sec. It does sound like these are synonyms, but I would be a little bit more careful with enthalpy. Okay? I think it's ionization energy. You can cross check with your chem teacher. Chalo, chalo आगे बढ़ते हैं. Anyways, so that's the basic idea. These 5 formulas you have to remember. But then, like in an advanced exam, I don't know if chemistry also has questions like this, but definitely, at least in the physics exam, right? They can ask some more questions. Like they can ask you about the angular velocity of the electron in the orbit. They can ask you its time period, de Broglie wavelength, linear momentum, kind of current the moving electron represents, right? And the kind of the amount of the magnetic field it will produce at the center of the atom. So they can definitely ask questions like this and beyond. But at least we could, we can get the idea with these 6. So just apply the physics, like for instance, quickly to go over these results. I'm sure you guys have been able to do this yourselves. So omega angular velocity is v by r. V का formula derive कर ऐसा अगर exam में आया, and if you do not remember the result, like I do not memorize results of v and r and all, but if you have memorized, good for you. If you have not, also it's not a big deal. If you haven't, divide v by r. Figure out what v is, figure out what r is, divide v by r. उतना time रहेगा exam में. If you're quick, you can do it quickly. उतना time रहता है. V by r divide करने में, then you get the result for omega. Okay. तो omega आएगा ऐसा, and you can just observe कि omega proportionality wise is proportional to z squared by n cube. In fact, if proportionality is all that is required, you don't need to actually substitute the entire formula of v. Just substitute what they were proportional to. So v can be written as z by n, r can be written as n square by z. That's enough to tell you कि omega being v by r is proportional to z square by n cube. Okay, तो वैसा omega का result आ रहा है. Moving on. Yes, Prithvi. Yes, yes, yes. That's the idea. Yes. Okay. Moving on. I'll come to that in fact. Moving on. Time period is 2 pi by omega. So if you have omega, you have time period. Just 2 pi by this, whatever this answer is. So 2 pi, 2 pi by omega. So NQ. Have I made some mistake? I think I have. नहीं, I have not. 2 pi काट दिया मैंने. Fair enough. N cube H cube ऊपर गया. 8 pi cube से 2 pi काट दिया नीचे. So fair enough. Time period आएगा n cube by z square के proportional. इसके उल्टा, इसका उल्टा. ठीक है? N cube by z square के proportional. But de Broglie wavelength, that's another thing they could ask. So de Broglie wavelength is h by linear momentum. Okay? Linear momentum is mass into velocity. Okay, this is an electron. Okay, so its momentum is mass times velocity. Okay, velocity का formula derive कर लो या याद है डाल दो. Accordingly आ जाएगा कि de Broglie wavelength is n h square by z 2 pi k m e square. You can see that de Broglie wavelength is proportional to n by z. Okay, and if you just wanted proportionality, h is a constant, m is a constant. De Broglie wavelength is therefore inversely proportional to velocity. So velocity का उल्टा दिख रहा है, n by z दिख रहा है. Linear momentum, similar idea, mv directly. Okay, so without the h, just this term is your linear momentum. Okay, the linear momentum is proportional to z by n. Current. Okay, then they can make the question a little bit more interesting. थोड़ा electromagnetism डाल सकते हैं इसमें. So an electron rotating in a circular loop, any charge rotating in a circular loop, okay, can be, in a sense, can behave like a current moving in a circular wire. Because what is current moving in a circular wire? Is nothing but charge crossing a cross section of the wire, right? So वैसे ही electron moving in a circular loop can be visualized as current going through that circular loop, because it's basically some charge moving through any particular cross section of the loop. So on an average, kitna charge is crossing in how much time? So we know ki exactly one electron. I'll answer that. Okay? So exactly one electron is crossing any particular cross section of the loop in one time period. हर एक रोटेशन में एक इलेक्ट्रॉन, मतलब एक ही इलेक्ट्रॉन है, तो उसके हर रोटेशन में वो इलेक्ट्रॉन कोई भी क्रॉस सेक्शन को क्रॉस करता है. सो द चार्ज क्रॉसिंग इज E, मैग्नीट्यूड के बारे में बात कर रहे हैं. चार्ज क्रॉसिंग इज E and the time period is this. So E by time period is current. E by time period is current. तो बस time period को उल्टा कर लो और E से multiply कर लो and you get a result like this. Get a result like this. Okay. So current is Z square by N cube के proportional. Time period का उल्टा. Charge of an electron anyways constant है, तो current ऐसा आ रहा है. Okay, so far so good. The last one, I thought I'll make you apply what you have learned from magnetism. But my question to you guys is, have you learned already to find magnetic field at the center of a current carrying loop? Have you been taught that? Okay, you've been taught that. Great. So you know that the formula is mu naught I by 2r. All right. So this electron is now behaving like a current carrying loop, because in that circular path, some charge was crossing the cross section in given amount of time, right? So it's behaving like a current carrying loop. So electron के कारण center पे magnetic field निकाला, तो वैसे ही current carrying loop के कारण तुम center पे magnetic field निकालोगे. That's how it works. That's exactly how it works. Okay. So what you will do? B को लिखो mu naught I by 2r. Mu naught I by 2r. All right. So mu naught I is this entire value. तो वो कॉपी पेस्ट किया इधर नीचे by 2 times r. ये थोड़ा मेहनत करना पड़ेगा to get the final answer. The idea is very simple. You understood how I is found. and you've understood how R is found. You probably, some of you may remember the value of R. First, mu naught I by 2R. Carefully simplify karo, and you get this answer. These kind of questions are asked in the advanced exam. Okay, they can totally ask questions like this. Okay, so now coming to what we have to remember and what kind of questions they can ask. So just to wrap this up, B ka answer, when you simplify that, comes out to be this nice big answer. Okay, and it comes out to be proportional to z cube by n raised to 5. वो भी logically कर सकते हो. I is proportional to z square by n cube. मतलब proportionality ही चाहिए तो z square by n cube को n square by z से divide कर लो. You'll get z cube by n raised to 5. Now, like Sophie asked, sir, do we need to remember these proportionalities? No, not for the last 6. Because last 6 were random practice questions. Okay, I was just testing what else do you know about an orbiting electron. Can you find its omega? Can you find its current given that's an orbiting charge? Can you find B? Can you find de Broglie wavelength given its momentum and velocity? So these 6 were just practice questions. You wouldn't want to remember anything over here, right? But this is a glimpse of what can be asked in the advanced exam. Now the way they can ask, so whenever they ask, you will derive, because you're not going to, there's anyways a lot that you need to remember from other subjects and other parts of physics itself. तो बेकार के चीज इन एक ये स्पेसिफिक चीज याद करने को कितना मेहनत करना पड़ेगा, एंड उसका आने का प्रोबेबिलिटी इज सो स्मॉल. एग्जैक्टली यही आने का प्रोबेबिलिटी इज सो स्मॉल, राइट? सो नॉट वर्थ द एफर्ट, especially given that you don't need to remember, you can derive it. थोड़ा मेहनत से you can derive, उतना टाइम एग्जाम में होता है. अब एग्जाम में क्वेश्चन कैसा आएगा? एक तो एग्जैक्टली ऐसा आ सकता है, फॉर्मूला फॉर बी. They'll say consider the electron rotating around the atom. It's like a current carrying loop. What is the magnetic field? It subtends at the center. तो एक तो या तो एग्जैक्ट ये सवाल हो सकता है, and you can have different options looking like this. दूसरा हो सकता है what is it proportional to. तो फिर एक मतलब डायरेक्ट ऐसा टाइप का सवाल हो सकता है कि that B is proportional to Z cube by n raised to 5 and other similar looking options. ठीक है? और okay, हाँ, cool. I hope you understood it now. ठीक है? तो एक तो ऐसे टाइप के क्वेश्चंस है, एंड बाकी फिर ऐसा क्वेश्चन हो सकता है कि so you guys try this. So just try this. All right? And chalo, you guys have derived omega at home. That's good for you. But if you feel the need to derive it again for this question, imagine this in the exam, go ahead and derive the result. Okay? But the question right now in front of you is, find the ratio of the angular velocity of an electron in the second orbit of a hydrogen atom, of an H atom, to that in the third orbit of a helium plus ion, of an He plus ion. So find the ratio of the angular velocity of an electron in the second orbit of an H atom to that in the third orbit of an He plus ion. Simple है, ये वाला कर लो. You feel you need to derive anything, derive it. Sir, when will we start AC current? AC current is not in my track. AC current is in your electromagnetism track. मैग्नेटिज्म के बाद EMI होगा, EMI के बाद AC करंट होगा. Yash, just give me a second. Yeah, that's correct. Yeah. Sorry, different people are asking different things. Yeah, सही है. Yash, good, very nice. Shivang, very nice. Uh, Deven, I didn't hear that. I didn't hear that. Crazy. Panadya, nice. After modern track or after modern physics, will my track be over? No. So after modern physics, my guess is most likely मेरे track में we'll have the mains syllabus. So there are some main specific chapters वो हम करेंगे. You can say कि advance का syllabus हो जाएगा. एक तुम्हारा units and dimensions, थोड़ा errors बाकी रहेगा, वो भी करेंगे. ठीक है. So after modern physics वो करेंगे and errors भी कर लेंगे and mains का भी syllabus कर लेंगे. That'll be my plan. हाँ, then उसके बाद you guys will have revision lectures. Case will schedule them. You'll have to check the dates. I think first exam Feb के आसपास कुछ होगा mains का. Okay, तो ये वाला हो गया. तो just quickly discuss this. Simple है. Now like these questions, मान लो ऐसा सवाल exam में आया. Forget that we just saw the result. ऐसा सवाल exam में आया. So the point is in this question, what are we playing around with? Okay, so we are playing around with just the atomic number and the orbit number. Okay, so second orbit of H, third orbit of He plus. So we're just playing around with Z and N. Okay, there is no any other complication. So all the other terms that would be there in the actual formula for omega are actually constants. They're all constants. E, M, K, वगैरह, they're all constants. Such a question can be done by a simple derivation involving only the variables n and z. Right? So मान लो ऐसा सवाल आया ओमेगा का फॉर्मूला तुमने मेमोराइज नहीं किया है. This question only involves z and n, so you can just do a simple derivation involving z and n. So the idea is, you know that omega is v by r. You know v is proportional to z by n. That is important to remember. R is proportional to n square by z. That's also important to remember. So z by n divided by n square by z is z square by n cube. ऐसा तुम एक लाइन का डेरिवेशन कर लो. जैसे ही कर लिया, you got कि omega is proportional to z square by n cube. That proportionality was all that you needed in this question. You'll say omega for hydrogen in the second atom upon omega for helium plus the third atom is z square for hydrogen upon n cube for hydrogen. So that's 1 square by 2 cube because hydrogen के लिए वो second orbit में था. And same thing for helium. So helium का z is 2, 2 square by 3 cube. Okay, by 3 cube because helium के लिए वो third orbit में था. So this gives me what? This gives me 3 cube ऊपर गया 27, 2 cube और 2 square नीचे जुड़ के क्लब होके 2 raised to 5, 32 हो गया. So this is simple. ठीक है. तो ऐसा you can imagine a question being asked for magnetic field, the question being asked for de Broglie wavelength, current, कुछ भी पूछ सकते हैं. ऐसे क्वेश्चन समझ लो कि यार सिर्फ z and n का खेल है यहाँ पे. So just you don't even need to use the entire formula of V and R. You just need to use the proportionalities. You need to figure out what these terms are in terms of V and R, substitute the proportionalities and accordingly find the ratio. Okay. और कई बार ऐसा ये जो जिस तरीके का क्वेश्चन पूछा है, ऐसा क्वेश्चन फर्स्ट 5 टर्म्स के लिए भी आ सकता है. Like just find the ratio of total energy in second orbit of hydrogen to third orbit of helium. So you can do all of those things easily. You have to remember the proportionality formulas at least. Okay. In fact, I would say that's enough. But if you remember the actual formula for total energy, then that's good. Now, consider this another type of question. Another way the JEE exam can test what we did just now. The other way they can test what we did through those 10, 11 questions is asking you a question like this. So pay close attention to this question. They're saying in an imaginary world, the charge of an electron is 3e and its mass is 4m, where m and e are its charge and mass, sorry, the other way around, where e and m are its charge and mass respectively in the real world. Okay. Find, तो ऐसा इमेजिनरी वर्ल्ड में जा रहा है जहाँ पे इलेक्ट्रॉन का चार्ज अलग है, इलेक्ट्रॉन का मास अलग. Electron ka charge in the imaginary world is 3 times that in the real world. Mass is 4 times that in the real world. Find the ratio of the angular velocity of an atom. So again, I'm working with omega. Find the ratio of the angular velocity of an atom in the ground state. Okay, ground state, by the way, means first orbit of an H atom in this imaginary world to that in the real world. Okay, so इसमें I'm दोनों केस में मतलब it's a hydrogen atom in the ground state for both cases, real world and imaginary world. Okay, but find the ratio of the omega in these two worlds. Now in this question, again, if you didn't derive a formula for the previous question, but you feel you need a formula for omega, please derive it. Okay, if you remember V and R, that's helpful. Don't know V, don't know R, you may have to derive that as well. Just see for yourself how quick you can be. Omega का formula आ गया, that should help you answer this question. Please try this out. Very nice, Shivang. That's good. Very nice, Emma. सही है पृथ्वीराज. Very nice. Say yeah, Yash. Good. The others, let me know if you need a little bit more time. Take a minute more. Come on. All right. Good. So इसमें like now this question, ये जो question है, यहाँ पे अब proportionality का खेल नहीं है, because the normally when we find these terms, we always find their proportionality with respect to z and n, because we in general know that all the other terms are constants. Mass of an electron, charge of an electron, Planck's constant, pi, ये सब constants है. They're not going to change. K, they will not change. But ऐसा बना रहा है जेई सवाल और जेई ऐसा बनाता है, तो अगर वो लोग ऐसा सवाल बना रहे हैं where they are saying there is an imaginary world जहाँ पे इलेक्ट्रॉन का चार्ज और मास वगैरह अलग है, then now you have no option but to, now in such a question you would need the exact formula for omega. अब बस proportionality जो z square by n cube है उससे काम नहीं चलेगा, because now you're concerned with what, how omega relates to the charge of an electron and the mass of an electron. तो उसका E और M के साथ क्या proportionality वो तुम्हें निकालना पड़ेगा. And if you're like me, there's no harm to be like that, but if you're like me and you don't remember the results for B and R, okay, and a question like this comes, there's no problem. As quickly as possible, you will do what was done on page 9. You'll find R, the actual formula. You will do what was done on page 10. You'll find V, the actual formula. Okay, if you have memorized this, then good for you. But if you have not, also you should not panic. It should not take time to find R, should not take time to find V. Once you get them, divide the two. Okay, once you get them, divide the two. You divide the two. Sorry, excuse me. When you divide the two, you get the exact formula for omega, the complete extended formula. That is what you will need. So now in this formula, then अब देखो हो क्या रहा है. तो ये question एक imaginary world में जा रहा है. उस imaginary world और ये world में ओमेगा compare करना है. This time he is not changing the atom, so it's still hydrogen. So Z is like a constant. मैं उसका भी सवाल बना सकता था, तो Z भी वेरिएबल होता है ना, तो you'd have to keep track of that as well. फिर ऑर्बिट भी चेंज नहीं कर रहा हूँ, दोनों में ग्राउंड स्टेट रखा है, तो N is also a constant in this question with respect to the two cases. I could have changed that as well. I could have said first orbit helium, third orbit lithium. So I could have put in those variations as well. यहाँ पे हमने वो नहीं किया है, तो Z and N are like constant. So what is really varying in this question then? E and M. So how does omega relate with E and M? Omega is proportional to E to the power 4 times M. Now, omega in the imaginary world upon omega in the real world is going to be based on that proportionality. Imaginary world में electron का charge raised to the power 4 into imaginary world में electron का mass, that's 3 and 4m as given in the question, divided by real world में electron का charge raised to 4 into electron का mass, which makes the answer 3 raised to 4 times 4. 3 raised to 4 is 81. 81 times 4 is 324. 324 is to 1 is the answer. All clear? So that in a way, like, this is how questions will come in boards. Majority of the questions will come like this. Any doubt in this so far? None? एक टिपिकल वेरिएशन ये लोग जो फिजिक्स में स्पेशली कर सकते हैं, ओके, and this has a long derivation. You can maybe just remember the result, remember the idea, but one typical variation that they will do is they will say consider the fact कि इलेक्ट्रॉन का मास न्यूक्लियस के कंपैरिजन में नेग्लिजिबल नहीं है. ऑलराइट, right now, like we are saying कि इलेक्ट्रॉन बहुत हल्का है in comparison to the nucleus. So in fact, in reality, you can't say that the nucleus does not move at all, because if the electron is experiencing a force, the nucleus also should experience a force, and the nucleus should also have an acceleration. Nucleus should also be moving. What does not move? Similar to a double star system, exactly. So what does not move is their center of mass. Because from outside the system, you can see that there is no external force. When there is no external force, the center of mass does not move. So the center of mass is going to be fixed. And क्या होगा, ये दोनों, जैसे in a double star system, both the stars revolve about the center of mass. Okay, both the stars revolve about their combined center of mass. यहाँ पे actually वो होने वाला है. But the thing is, electron इतना light है न्यूक्लियस के कंपैरिजन में कि न्यूक्लियस का वैसा उस सिस्टम का सेंटर ऑफ मास लगभग न्यूक्लियस के अंदर ही न्यूक्लियस के सेंटर मास पे लाई करता है लगभग. The electron is so light that the center mass of the combined system is very close to the nucleus. All right. So in a way, things are fair. It's fair to assume that the nucleus does not move, but still, if you want a more precise answer, then you have to take into account that they both revolve about their center of mass, which is in reality going to be very close to the nucleus, but they do move around there about the center of mass. So therefore, for a more accurate result, some corrections have to be made. Sometimes ऐसा भी कर सकते हैं ये लोग कि वो इलेक्ट्रॉन के जगह एक दूसरा चार्ज पार्टिकल दे सकते हैं, which could be heavier, and where then for the exact answer you'll have to take into account that the nucleus is going to move. Okay, now it's not a light electron rotating around the nucleus, it's a heavier particle. So for example, muon, a muon or a muon, muon, I think muon is how I will pronounce it. So a muon is a heavy charged particle, very heavy particle compared to an electron, which is still charged. If that is rotating about the nucleus, okay, then uske सवाल में we'll have to take some corrections. तो क्या है वो corrections, एक बार फटाक से देखते हैं. I'll just quickly take you over the derivation. You can understand it. If you can do it yourself, that's good. But I think the bottom line is more important than the derivation itself. So final result क्या है? That's a little simple to remember, and वो भी याद कर लिया तो चलेगा, because as it is, this is a very small topic, right? इसका भी आने का chance काफी कम है, but you can remember what the final result is. एक दो छोटा सा change करना पड़ेगा. फंडा क्या होगा? Quickly, just to take you through the derivation, you will have these two particles. This is M1, which is my nucleus, moving with a velocity v1. Okay, this is M2, my electron, moving with a velocity v2. Remember, they're not moving. As a motion is not about the nucleus, but motion दोनों का है, circular motion दोनों का है about their combined center of mass. Okay, and both have the same omega. Both will have this in any double star system. Omega is the same. क्योंकि ऐसा नहीं हो सकता है कि ये 90 डिग्री रोटेट किया और वो 180 डिग्री रोटेट किया और सिस्टम अब ऐसा दिख रहा है. Right? They will always rotate the same angle, and that can be proved in any double star system. So omega is going to be the same. Acha, let R be the distance between the nucleus and the electron. right? In the traditional sense, that's also what R was. So let R be the distance between the nucleus and the electron. R is not the radius of the electron. The radius of the electron is going to be something smaller. Center of mass के formula से you know कि that electron का distance from the center of mass is going to be nucleus का mass into R upon m1 plus m2. So m1 R by m1 plus m2. So electron का radius is this particular value. You can put in some point, put in some equations together. So m1 v1 is m2 v2. Okay, linear momentum conservation, center mass कहीं जा नहीं रहा है. न्यूक्लियस का मोमेंटम ऊपर की तरफ, इलेक्ट्रॉन का नीचे की तरफ, नेट मोमेंटम जीरो होना चाहिए. नेट मोमेंटम जीरो होना चाहिए. तो m1 v1 should be m2 v2. r1 क्या है? Okay, nice guys, please ask questions if you didn't get anything. r1 is this, ये इधर एरोस बनाया ना. r1 है इलेक्ट्रॉन का डिस्टेंस सेंटर ऑफ मास तक, और r है इलेक्ट्रॉन का डिस्टेंस न्यूक्लियस तक. And I hope you know center of mass will divide this line in the ratio m2 is to m1, है ना? Center of mass divides the line joining two particles in the inverse ratio of their masses. जितना बड़ा m1 होगा उतना m1 के पास होगा. तो जितना बड़ा m1 उतना वो m2 से दूर, उतना वो m1 के पास, उतना m2 से दूर. तो distance of the electron from the center mass is m1 r by m1 plus m2. Did you get that? That is what I'm taking as r1. Okay, whoever asked that, please let me know if you got it. Okay, तो हाँ यहाँ पे फिर, हाँ great. तो यहाँ पे फिर थोड़ा adjustments, जैसे nh by 2 pi is angular momentum. Your center of mass is closest to the heavier mass. Why will it be closest to the smaller mass? भूल गए basics. Heavier mass के पास होता है. It's summation. हाँ, okay, cool, great. Coming back to this angular momentum, nh by 2 pi, n is nh by 2 pi, but the angular momentum itself, पहले तो सिर्फ इलेक्ट्रॉन का ले रहे थे क्योंकि we were assuming a model where the nucleus is at rest, right? But now combined system, total combined system का अगर तुम्हें angular momentum चाहिए, yes, if you want the angular momentum of a double star system, remember कि double star system में omega same रहता है. तो combined system का अगर angular momentum चाहिए about the center of mass, you'll have to use ICM, पूरा system का moment of inertia about the center of mass, into omega. पूरा system का moment of inertia is going to be reduced mass r square. I hope you have seen that. Center of mass of a two particle system is reduced mass into r square. Sorry, I about the center of mass of a two particle system is reduced mass into r square. It's very easy to derive. Just assume m1, m2, find the center of mass, find distances to the center of mass, and then find m like m1 r1 square plus m2 r2 square. Okay. By the way, I can see why there is this confusion. Sorry, I think this would be better named as R2. You can understand why there was a minor confusion. M2 का distance from center of mass will be called that as R2. That seems better. तो तुम M2 R2 square plus M1 R1 square जब निकालोगे, moment of inertia निकालोगे, तो तुम्हें mu R square आएगा. Mu R square क्या होता है? Reduced mass. Hope you've heard that before. हाँ, तो ये रिजल्ट देखा है ना, just for yourself, for you guys to be convinced. On a side note, m1 m2 ये distance है m2 r, where r is total distance, m2 r by m1 plus m2, और ये distance होता है m1 r by m1 plus m2, inversely proportional to mass. m1 से distance is proportional to m2, and m2 से distance of the center of mass is proportional to m1. And when you find moment of inertia, when you want to find n1 into iska square plus m2 into iska square, it becomes m1 m2 square r square upon m1 plus m2 का square plus m2 इसका square, m1 square r square, again r square, r2 क्यों लिख रहा हूँ, on m1 plus m2 का square. और इसमें तुम m1 m2 कॉमन ले लो, r स्क्वायर कॉमन ले लो, m1 प्लस m2 का होल स्क्वायर नीचे कॉमन ले लो, और यहाँ पे ऊपर m2 एक फर्स्ट टर्म में था, m1 एक सेकंड टर्म में था, and when you cancel them out, see, I'm sure you've seen this, and just giving you a recap, when you cancel them out, you're left with m1 m2 by m1 plus m2 into r square. m1 m2 by m1 plus m2 is mu. So moment of inertia about the center of mass is therefore mu r square. You can easily derive it. Okay? So actually, madam, this proof is quite long if I derive everything. We're just trying to reach the answer quickly. So I about center mass is mu r square omega. I hope you guys know that. Okay, reduced mass r square omega. Fir, just apply force, Newton's second law on the electron. On one of them is enough. So electron पे force है kz e into e by r square. अच्छा, यहाँ पे r क्यों? क्योंकि electrostatic force is dependent on the actual distance between them. It does not care about what is the radius of the electron. The electrostatic force is kz e square by distance का square. और इन दोनों के बीच में distance है r. So it's kz e square by r square. Electrostatic force is balanced by the centrifugal force. The centrifugal force on this guy is going to be m2 omega square, not r, but iska radius. The centrifugal force depends on the radius. Radius is not r, radius is big term. Right? So it's going to become m2 omega square into this big term, m1 r by m1 plus m2. You can nicely see how m2 m1 club होगा, m1 plus m2 भी club होगा, और यहाँ पे ये kz e square by r square mu omega square r होगा. Interestingly, m omega square r के जगह ये mu omega square r है. mu omega square r. अच्छा, फिर इसके आगे थोड़ा और मेहनत से जब सॉल्व करेंगे, अच्छा क्या करना है, बाकी r को उठा के हम इधर सब्स्टिट्यूट कर लेते हैं. ऊपर वाले इक्वेशन से r को उठा के सब्स्टिट्यूट कर लेते हैं. r है क्या? nh by 2 pi divided by mu w का रूट. nh by 2 pi divided by mu w का रूट. I'm not substituting r, I'm so sorry, I'm substituting omega. Omega को substitute कर लेता हूँ. ठीक है, done that. तो nh by 2 pi by mu r square is omega. nh by 2 pi by mu r square is omega. तो omega का square हो जाएगा nh by 2 pi by mu r square का square. I'm rushing through this because this derivation is not very important. You can do it once to convince yourself, but the result is going to be a little easy to remember. Okay? फिर भी है ना, you just see how it comes from, so you can have faith in the result. So nh by 2 pi mu r square का square makes it n square h square by 4 pi square mu square r to the power 4. ये जैसे ही लिखा बहुत कुछ कट जाएगा. ठीक है, we have placed it over here, so the rest of the terms in that equation are this. ठीक है, अब इसमें क्या क्या कट जाएगा, तो r और r raised to 4 कट के r क्यूब रहेगा, और r स्क्वायर और r क्यूब कट के राइट हैंड साइड में r रह जाएगा. Okay, so this r square and this r together form an r cube which will take out that 4. तो नीचे बस r रह जाएगा. ऊपर वाला mu यहाँ का स्क्वायर हटा देगा. Okay, so those were some changes. Final result looks very interesting. Final result is when I take r to the left hand side, I get n square h square by z 4 pi square e square k mu. What is the change? What is interesting about this result? पूरा मेहनत करने के बाद क्या रिजल्ट क्या है ये? If you look carefully, ये वही रिजल्ट है. सेम n square h square by z 4 pi square e square k m के जगह n square h square by z 4 pi square e square k mu आ रहा है. That's so easy to remember now, है ना? So this will save us a lot of time. We don't have to derive this ever again. बस इतना याद कर लो कि r अब m नहीं, r में m के जगह mu है, and I've summarized that on the next page. ठीक है, r के फॉर्मूला में m के जगह mu है. When you go on to find velocity, so nh by 2 pi is I into omega mu r square omega. R omega is velocity, but bear in mind r is actually the distance between nucleus and electron. So r omega is not exact velocity of the electron, it's the relative velocity of the electron. Nucleus के frame में जाओगे तो इलेक्ट्रॉन का जो वेलोसिटी दिखेगा वो r ओमेगा होगा, या इलेक्ट्रॉन के फ्रेम से न्यूक्लियस का वेलोसिटी दिखोगे तो वो r ओमेगा होगा. r ओमेगा एक्चुअली इज रिलेटिव वेलोसिटी. r ओमेगा इज रिलेटिव वेलोसिटी. Relative velocity का formula is nh by 2 pi mu r, and when you substitute the value of r you get this result. Again, moral of the story, what's interesting about this result is this is the same result we had for velocity earlier as well. Those who have memorized it probably can see it directly. Z 2 pi k square by nh, same result we saw on page 10. Yeah, that's quite interesting. In fact, it looks like हमने r में mass के जगह mu डाल दिया. Velocity में mass का term ही नहीं था तो कुछ change दिखा ही नहीं, वैसा सीन हो गया. Mass के जगह बस mu डाल रहे हैं. Somehow mass के जगह mu डालना magically is just magically नहीं, but is ultimately changing. Make is all you need to do. Is all you need to do. Mass के जगह mu डालना is all you need to do to solve this double star type system. If you know the results for single star, double star में बस m की जगह mu डाल दो. That's kind of what's happening. Kinetic energy भी अगर तुम देखोगे kinetic energy का formula, ठीक है, तो मैं सबके लिए कर सकता हूँ, but let's just stop at kinetic energy. That proves the point. Total energy will be similar. So kinetic energy is half I omega square. Half ICM omega square, right? Center of mass not moving, that's the only term you have. Now half ICM omega square, where ICM is mu r square. R square omega square is velocity का square. Again, कौन सा velocity? Relative velocity. ये velocity डाल दो तो तुम्हारा आंसर काइनेटिक एनर्जी के लिए ऐसा कुछ आएगा. अगेन इसमें द इंटरेस्टिंग ऑब्जर्वेशन इज m के जगह mu आ रहा है. m के जगह mu आ रहा है. So finally, the conclusion in all of this, the conclusion is, I'll just show you page 17 and then you guys can ask if you have any doubts. The final conclusion, moral of the story, एक बार मैंने derivation देख लिया, तुम्हें कभी खुद से try करना, you can try. It'll, again, just be a good revision for several concepts. But the point is now the reduced mass conclusion is in the formula for R, replace M with mu. And also remember that r is no longer the exact radius of the electron. It represents the distance between the electron and the nucleus, not the distance of the electron from the center of the circle. So not the radius, not the distance of the center of mass. R is actually the distance between the nucleus and the electron. That R का formula is exactly the same as before, where only m की जगह तुम्हें mu डालना है. M की जगह mu डालना है. Okay. Similarly, the next one, in the formula for V, in the formula for velocity, पहले there was no mass term in the Bohr's formula for velocity. There is no mass term. तो mass नहीं है तो mu भी नहीं है, because mu के जगह ही हम मतलब m के जगह ही mu डाल रहे हैं. So because there was no m, there will be no mu. make no changes, that's it, same formula as before. But एक चीज का ध्यान रखो कि यहाँ पे भी the velocity we are referring to is not the velocity of the electron, but it's actually the relative velocity between the nucleus and the electron. Is the velocity of the electron as seen in the frame of the nucleus. All right. And the last one, in the formula for kinetic, potential, and total energy, replace mass m with mu. So in the formula for kinetic, potential, and total energy, okay, yeah, I'll show the previous page again. तो काइनेटिक पोटेंशियल टोटल एनर्जी में जो भी फॉर्मूला है, पहले जो भी फॉर्मूला था उसमें मास को म्यू से रिप्लेस कर लो, और इसमें भी यहाँ ध्यान रखो कि काइनेटिक एनर्जी, टोटल एनर्जी वगैरह, दैट विल बी दैट ऑफ द एंटायर एटम, नॉट जस्ट द इलेक्ट्रॉन. दैट काइनेटिक एनर्जी विल बी पूरा एटम का एनर्जी, न्यूक्लियस इंक्लूडेड. पहले न्यूक्लियस इंक्लूडेड नहीं था क्योंकि न्यूक्लियस वाज नॉट मूविंग, जीरो था उसका काइनेटिक, बट अभी इंक्लूडेड है. तो बेसिकली मॉरल ऑफ द स्टोरी, जो फर्स्ट 5 फॉर्मूलाज तुमने याद किया है, I think you guys have gone one step ahead and you have even memorized them. Yeah? Others can maybe just derive them. Those first 5 formulas, may just m को mu से replace कर लो and you'll be ready for a system where you have to consider the nucleus also to be moving. Okay, तो एक question करेंगे. हाँ, यश एक सेकंड ना, तो I'll answer that. So just, but lastly, just remember कि r is distance between the nucleus and the electron. Closing note, r तुम निकाल सकते हो फॉर्मूला से अच्छे से. r निकल गया, then it's a center of mass question to find r2 and r1. वो स्पेसिफिकली पूछा है तो r निकालने के बाद वो भी निकाला जा सकता है. That will just be a center of mass type question. फिर relative velocity भी, एक बार relative velocity निकल गया, relative velocity is the one in these formulas. अगर relative velocity निकल गया तो भी individual velocities निकाल सकते हैं using momentum conservation, using the fact कि the center of mass should not be moving, right? तो you can, वहां से भी तुम m1 v1 is m2 v2 से भी तुम v1 और v2 के individual values निकाल सकते हो. If you know what the relative velocity is, combining that with this equation at the top, you can find v1 v2. So one of you is asking me, sir, can we find the energy of an electron? I think, yes, you can. Only thing, they may not ask that because the beauty of the question is gone. It's just going to be a long question. But to find the energy of the electron, once you get total energy, total energy, in fact, वो भी करने का जरूरत नहीं है. Once you get velocity of the electron, you can get its kinetic energy. तुम velocity of relative velocity of the system निकाल दोगे, वो निकालने के बाद v is v1 plus v2, m1 v1 is m2 v2, वो दो simultaneous equation से तुम v2 यानी कि इलेक्ट्रॉन का velocity निकाल सकते हो and वहां से kinetic energy निकाल सकते हो, if that is what they have asked. But that in a way does, they may not ask that. But yeah, if they ask that, that's what you would do. This is the kind of question where you're really expected to use the concept of reduced mass. Okay. So, यहाँ पे देखो, a muon has a mass roughly 200 times the mass of an electron. Yes, some imagine it's not imaginary. A muon is a particle which has a mass roughly 200 times the mass of an electron and 1/9 of the mass of a proton. इतना information दिया है. Its charge is the same as that of the electron. तो उसका भी charge -1e है. Consider an atom where a muon rotates about a proton. Okay, consider a simple atom of a muon rotating about a proton. Okay, proton heavier है, but only 9 times heavier. what is the total energy of the atom in the ground state in electron volts? Can you please try this? Total energy of the atom in the ground state in electron volts. It was asked in a KVPY exam, is it? Okay. I thought I made this up, but maybe it's maybe they must have used the information of a muon, which is, and the whole idea of the question also may be similar. So for your reference, अब technically एग्जाम में तुम्हें टोटल एनर्जी भी खुद जो बेसिक फॉर्मूला है वो भी डिराइव करना पड़ेगा, तो तुम्हारे रेफरेंस के लिए मैंने डिराइव कर लिया. ओके, नाइस देवेन. अपेरेंटली इन अ सिमिलर वे म्यू1 का सवाल केवीपीवाई में पूछा. Sir, is our JEE syllabus enough to crack any engineering exam in the world? Do you mean engineering entrance exams? Like BITS, movie India ka BITS and mains, and mains to करी हो, BITS and whatever, BIT वगैरह. बिल्कुल यार. But of course, BITS का अगर देना है तो थोड़ा you'll have to check कि they also have logical reasoning and English as a part of the syllabus. So that would need a little extra preparation for some. And foreign engineering exams, I'm not sure what the exact procedure is. But yeah, foreign बाकी कोई भी country का engineering entrance exam is not of the level of your JEE. So all those who appear for SAT and all find that very easy. I don't think any engineering exam JEE के level का. These are the common ones we know about. In fact, यार MBA entrance exam जो होता है CAT in this country, that itself from a maths perspective seems so easy for those who are prepared for IIT. And it seems a big challenge for those who are not from an engineering background. Yeah, JEE is one of the toughest exams you'll give in this country. CAT has its own challenge for MBA. I've given the CAT without any preparation. So CAT has its own challenge. But that's more of a speed challenge. And uska jo math wala part hai, usme we'll not find any challenge at all because it's really simple compared to whatever we've done in our JEE. The logical reasoning is definitely of a very high level, very good. English is also quite tough in the CAT. Is it? Okay, good. Yes. So JEE preparation in a way gives you a good solid ground. Especially the best thing about the JEE preparation is this is one place where you're actually it focuses on applying logic, especially the advanced exam. which is why even I'm trying to tell the main students also to, in a way, prepare as though they're preparing for the advanced exam. You can't just have an attitude where you just memorize formulas and keep a mains mentality. Prepare for the advanced exam, because that will help you for life, because this is one place where you're really applying stuff in a logical manner. Other places just been theory and memorizing stuff. Yahan pe you're really exercising your brains, you're benefiting yourselves. Okay, cool. Iska answer क्या आ रहा है guys? Muon is roughly क्या आ रहा है इसका? Let me just cross check. Okay. Doesn't seem to match with mine. I could also be wrong. But see if you want to cross check that again. Moral, एक बार just to give you a hint. Please take some time. 2 minutes ले लो. Hint is this. Yes, Purna, very nice. That's correct. And Yash, again, I'll have to, that doesn't seem to be the answer I got. डिस्कस करें बस तो बेसिकली इसमें आइडिया क्या है, तुम जैसे तुमने मान लो टोटल एनर्जी का फॉर्मूला डिराइव किया, ऐसा क्वेश्चन जहाँ पे यू सी कि यार मुऑन हैवी है और सेंटर बीच में प्रोटॉन है एंड इनका मास कंपेरेबल है, सो दैट्स वन वार्निंग साइन की प्रोटॉन तो अब मुऑन से इनफाइनाइट टाइम्स, मुऑन या म्यूऑन से इनफाइनाइट टाइम्स हेवियर नहीं है, सो द प्रोटॉन इज आल्सो गोइंग टू मूव. All right, the center mass is not exactly going to lie at the proton. It's going to be between the proton and the muon, closer to the proton, but somewhere in between. So proton move karega. So that's your hint ki you have to use reduced mass wala conclusion. Reduced mass wala conclusion क्या बोलता है, जो भी तुम्हारा फॉर्मूला है टोटल एनर्जी का, सेम फॉर्मूला रखो, मेक वन माइनर चेंज, m के जगह mu डाल दो. Now how do I use that? First and foremost, let me find what mu is. So what is mu? It's the reduced mass of my muon proton system. First, let's figure out that reduced mass. So muon का mass into proton का mass by दोनों का sum. Mass का sum. Proton का mass is 9 times muon का mass. Okay, I'm trying to write mu in terms of muon का mass. So proton का mass को मैंने 9 mm मतलब muon का mass से replace किया. So what does this become? So m ऊपर है 9 mm square, नीचे है 10 mm, तो mm काट दो. Okay, so you're left with 9 by 10 mm. So reduced mass is 9 by 10 times muon ka mass. Fair enough. That's good. Let's write this in terms of electron ka mass, because the original formula was for the mass of an electron. यहाँ पे दो चेंज हुआ है, एक तो इलेक्ट्रॉन को म्यूऑन से रिप्लेस किया, on top of that proton is now in a way, in a way it's going to move as well. So we have to take into account that the proton is also moving. तो म्यूऑन का भी मास को म्यू से रिप्लेस कर रहा है. तो म्यू इज 9 by 10 mass of muon. Muon itself is 200 times mass of an electron. Is 200 times the mass of an electron, making mu 180 times the mass of an electron. Now, okay, I want to find the total energy of MP, मतलब muon proton system. Okay, MP. I want the total energy of the muon proton system. I know the total energy in a hydrogen atom. We know it's 13.6 minus 13.6 electron volts. So we are using that. So I know the total energy in the ground state of a hydrogen atom. Inka ratio muon particle wala muon proton total energy upon hydrogen atom ka total energy is going to be what? So if you look at the formulas, I said muon proton wale system ka formula exactly same hoga. A muon even has the same charge. The only difference is the fact that m is going to be replaced with mu. Now total energy was proportional to m. So total energy being proportional to m, total energies ka ratio will be m ka ratios. Ab m in the muon proton system, I'll have to use as reduced mass, and m in the hydrogen atom system, I'll have to use as the mass of an electron. I know कि reduced mass is 180 times the mass of the electron. Therefore, muon proton system ka total energy is 180 times hydrogen atom ka total energy. So it's 180 into minus 13.6, which you can carefully multiply and you will get 2448 electrons, electron volt. समझा? कैसा सवाल आ सकता है इसमें? जैसे अगर रिड्यूस मास नहीं करते तो टोटल एनर्जी कैसे निकालते थे? टोटल एनर्जी ऑफ द म्यूऑन सिस्टम अपॉन टोटल एनर्जी ऑफ द हाइड्रोजन एटम सिस्टम would be mass of muon upon mass of electron. वैसा करते थे, right? वैसा करते थे, given that total energy is proportional to mass. बस इसमें थोड़ा फर्क ये है कि यहाँ पे mass of muon के जगह 9/10 of mass of a muon use कर रहे हैं, because we are taking into account कि in this case the proton definitely would be moving. So instead of this being 200, just because muon is heavier, this should have technically been 200, but reduced mass के कारण वो 200 के जगह 180 हो रहा है, वो ratio 180 हो रहा है. Did you guys get this? ये समझ में आया? आया ना? Please respond. आया? Okay, great. चलो then let's थोड़ा लंबा लेक्चर आज है. Yeah, but let's ये part तो I think अच्छा. What is the ratio of masses above which we consider masses comparable? Above which no, I mean it's थोड़ा एक field based है, like see, you can see that in general, if you keep using this formula, see, proton ka mass is greater, right? So this fraction is always going to be less than 1, and jitna bada wo proton ka mass hoga, utna close this will be to 1. Like, you guys understand limits. So if MP is a lot bigger than MM, this fraction is going to be closer and closer to 1, and mu is going to be closer and closer to mm, the smaller mass, right? So when MP seems comparable, when would it see comparable? I think ये जो 10 times वाला ratio है is अभी अभी ये क्या था, 9 था, है ना, 9 times था, तो 1/10 नहीं, 9 times के कारण कितना हो गया, 9/10. Do you consider 9/10 to be far enough from 1? I would say yes, right? 9/10 is okay, far enough from 1. 200 का 180 होता है. But had MP been 100 times this mass, okay, close to 100 times this mass, तो ये कितना होता था, 100/101 या 99/100 वैसा ले लो. So is now 99/100 close enough to 1? I would say चलो 0.99 काफी close to 1 है, right? So had the proton been 99 times as heavy, then reduced mass के कारण ज्यादा फर्क नहीं पड़ रहा है. Had the proton been 99 times as heavy, because I hope you're getting what I'm saying. 99/10 into 200 is 198. 200 की जगह 198 काफी close है. Because your own judgment, anyways, you're going to have options in front of you. If the question wants you to use reduced mass, it will be quite clear. Like 9/10 is definitely far enough from 1 to create some deviations. Right? That's a 10% difference. So that's far enough. 5% तक भी चलेगा. Yes, 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 Prithvi, yes. Yeah, I'll do that. Okay. Hydrogen spectrum में आ जाते हैं. ठीक है, you guys know this. Just to go over that terminology, an atom is said to be excited when the electron receives energy and jumps from the first orbit to a bigger orbit. Okay, so when an electron receives energy and jumps, because that's what excited people do, but it jumps from the first orbit to a bigger orbit, okay, then the atom is said to be in an excited state. When the atom de-excites, that is the terminology for saying the electron jumps to a lower energy level, comes back down to a lower orbit. Now, when it comes back down to a lower orbit, it's going from higher energy to lower energy. Where is this energy going? So this energy loss is going into a photon which it will emit. So it emits a photon of energy equal to the energy difference. It emits a photon of energy equal to the energy difference. Okay. Now, given all of that, the energy for transition when you're going from N2 to N1, let's say N2 is the higher energy level, higher orbit, N1 is the smaller, lower orbit. So when you go from N2 to N1, the energy for that transition, okay, all of the energy difference for that transition goes into emitting a photon. Photon ka energy is h nu or is hc by lambda. Okay, so that energy difference, N2 level ka energy minus N1 level ka energy, that energy difference is going into a photon. Okay, वो उतना ही photon, उतना ही energy का photon emit होगा. Now, En2 minus En1 itself is going to be, so what is the formula for total energy? Minus 13.6 Z square by N square. For N2, the formula will be minus 13.6 Z square by N2 square. This is the higher orbit. For N1, the formula is going to be minus 13.6 Z square by N1 square. This is the lower orbit. Okay? All said and done, वो बाहर का माइनस साइन अगर हटा दोगे तो यहाँ पे 13.6 1 by N1 square minus 1 by N2 square in electron volts. That will be the formula for the energy the energy gap between the higher level and the lower level, and that will thereby be the formula for the energy of the photon emitted. 13.6 Z square into 1 by N1 square minus 1 by N2 square. it's quite logical कि this first term that you write now उसमें वो छोटा orbit वाला term होगा, because जब n1 छोटा होगा तो ये term बड़ा होगा, ये term बड़ा होगा तो overall answer positive रहेगा. Then you know a photon is emitted, कितना energy है उस photon में वो तुम निकालने की कोशिश कर रहे हो, तो obviously उसका energy कुछ तो positive value होगा, frequency lambda positive होगा. So this term that you're trying to find has to be positive. So make sure, just ensure कि यहाँ पे n1 is the smaller one. Even if you goof things up and you get a negative sign, just ignore the negative sign. Okay? You can't figure out negative sign क्यों आ रहा है, you can ignore it. Now, that's the formula for that's the formula for the energy of photon. There is another formula that you guys will have for finding lambda. It comes from the same thing. 1 by lambda, if you look carefully, 1 by lambda, hc by lambda is this. hc by lambda is energy gap, delta E. So 1 by lambda is delta E by hc. So it's the energy difference by hc. So it's this entire term divided by h and c. Now, when you perform all of that, okay, when you divide it by 4.15 into 10 power minus 15 electron volts and divided by 3 into 10 to the power 8 meters per second, okay, very easy to do that as well. So you can work without it as well, because ज़्यादा problem नहीं है, यहाँ पे 13.6 है, and h into c is also pretty close. H into c is roughly 12.45. So as it is, they're very close. You can almost cancel them out. But nonetheless, once you do divide them, this is what you get. So 1 by lambda is 1.1 into 10 to the power 7 z square into 1 by n1 square minus 1 by n2 square meter inverse. Okay, this constant that you get, 13.6 electron volts divided by hc, that constant is called as the Rydberg constant. Okay, that constant is called as the Rydberg constant. The Rydberg constant is approximately 1.1 into 10 to the power 7 meter inverse. For a more precise value, just for your information, it's close to 1.097 into 10 power 7 meter inverse. But you can remember 1.1. Some books will tell you it's 1.1 into 10 to the power 5 centimeter inverse. Don't remember that one. Okay. In fact, just ignore that. Just remember it in the SI units, because you will further get confused if you remember it in centimeter inverse. Because centimeter inverse से meter inverse का conversion is the opposite of centimeter to meter. 1 centimeter is 10 power minus 2 meters. But centimeter inverse reciprocal है, तो 1 centimeter inverse is 100 meter inverse. That's why it's 1.1 into 10 raised to 7 meter inverse. So if you're going to be of a sound mind in the exam and you're not going to mess up, remember that. But otherwise, I would say just remember it in the SI units. Don't make things tricky for yourself. Meter inverse से nanometer तुम convert कर लोगे. Centimeter में थोड़ा just don't confuse yourself in the exam. So remember the meter inverse form. I'm also saying, if you want, you can remember the nanometer inverse form. So R in nanometer inverse is 1.1 into 10 to the power minus 2. Okay, that's just saying that because lambda हम technically nanometers पे निकालते हैं, तो वो भी option दे रहा हूँ, but इसको ऐसे ही याद कर लो, is my suggestion. And अगर तुम्हें lambda निकालना है, like most times questions that are asked are actually asked for you guys to find the value of lambda. My suggestion is, अगर तुम्हें lambda निकालना है तो तुम्हें इसका reciprocal लेना पड़ेगा, है ना? अब इसका reciprocal जब लोगे तो what is the reciprocal of, I mean lambda के formula में Rydberg का reciprocal आएगा. So I believe Rydberg का reciprocal, remembering that would have been more useful. So just to tell you, if I take the reciprocal of this, and I mean when I take the reciprocal of this, I get 0.9115. देखो यहाँ पे थोड़ा इधर दिखाया, Rydberg का reciprocal is 0.9115 into 10 to the power minus 7 meters. If I write that in nanometers, it is 91.15 nanometers. Okay, that I felt was actually most useful in calculations. तो अगर तुम्हें lambda का value निकालना है, ठीक है, तो एक तो इसका रेसिप्रोकल रहेगा, इसका रेसिप्रोकल होगा n2 स्क्वायर n1 स्क्वायर अपॉन n2 स्क्वायर माइनस n1 स्क्वायर, z स्क्वायर नीचे चला जाएगा, लेट मी पुट z, आई मिस्ड पुटिंग दैट, z स्क्वायर ऐसा नीचे चला जाएगा, यहाँ पे भी डालना है, ठीक है, एंड फाइनली Rydberg constant का reciprocal itself is 91.15 nanometers, या calculation purposes के लिए you can use 91 nanometers. So that will make your calculation super easy. So you just have to plug in n2, n1. N2 is the bigger orbit, n1 is a smaller orbit. I said if you mess things up, remove the minus sign. Okay? That's the only mistake you will make if you interchange n2, n1. So remove the minus sign. यहाँ से तुम्हें आंसर अच्छे से नैनोमीटर के फॉर्म में आ जाएगा. Any doubts so far? No doubts? Okay. Clear है? समझ में आ गया ना? So just to quickly go over the spectrum series. So this is how your energy levels look. Okay. So just to draw the first one, your first orbit, this is a hydrogen atom. The first orbit may energy is minus 13.6 electron volts. Next orbit may energy is minus 3.4 electron volts. Remember the formula is 13.6 Z square 1 होगा hydrogen के लिए by n square. So this 13.6 by 4 minus 13.6 by 4. So there's a large difference, okay, between the first and the second orbit. Next orbit, n equal to 3 minus 13.6 by 9. That is approximately minus 1.5 electron volt. Okay, sometimes it will be good if you can, of course, you can calculate these also, just to have an idea of what those specific values are. The difference is again just me pointing it out for you. If you remember the energy levels, you can find the difference also easily. Now, the back of your mind, the energy levels थोड़ा याद रखो, minus 13.6, minus 3.4. Familiarity with that is nice. Minus 1.5 electron volts, third orbit का है, okay, and then so on and so forth. So yeah, at least 3 तक it's important. फिर भी fourth का minus 0.85, that is 13.6 divided by 16, and minus 0.55 electron volts, that is 13.6 divided by 25. Back of the mind, just have these values, because kabhi they say ki a photon of energy 10.2 electron volt was absorbed or emitted, and they say find the transition. Photon of energy 10.2 electron volt was emitted from a hydrogen atom, find the transition. So I mean, for that 10.2 किसके बीच में है ना? So if you have some familiarity with the values of the energy levels themselves, you can figure out कि 10.2 इतना बड़ा जंप किसके लिए दिखेगा. So 3.4 and 13.6 के बीच में difference is 10.2. If it's 12.1, मतलब 1.5 and 13.6 के बीच में difference is 12.1. You don't have to memorize this. I'm just giving you an idea for your reference. And fourth and first level के बीच में difference is approximately 12.75. You want, you can approximate these numbers and just have a ballpark, just a mental picture of what these differences are or where these levels are. 2 and 3 के बीच में, 1.5 and 3.4 के बीच में 1.9. So the gap between the first and second is a lot bigger than the gap between the second and the third. The gap between the third and the fourth is again further smaller. Okay, so maybe you can remember these or be familiar with these. 10.2 पहले दो के बीच में गैप, फिर 1.9 अगले दो के बीच में गैप, फिर 0.65. Okay, first and third के बीच में gap is 10.2 plus 1.9 to 12.1. Okay, you will not be clueless. I mean, you can of course work out numerically if they tell you इतना energy of photon emitted है. थोड़ा solve करके you will get used to seeing 3. In fact, if you go through the HCV, I think by the time you're done with it, you will get used to seeing 3.4 several times. वो मन में बैठ जाएगा. 3.4, 1.5. वो at least ये तो पहले 3 energy levels के values बैठ जाएंगे and you'll be used to seeing the differences between them. 10.2, 12.1, 1.9. You'll see them often. You'll get a hang of it. It can be done without memorization also. Acha. Finally, as n tends to infinity, the value tends to 0. Total energy ka formula, when you're far away, value tends to 0. Okay? That's when your kinetic energy and your potential energy both become 0. Now, तो ऐसे बहुत सारे energy levels है. इसमें just, I think we're almost out of time, so I'll quickly wrap up. We'll continue tomorrow. But I just want you to remember that these energy levels are not, ऐसा uniformly spaced. Sometimes the way we draw things confuses us later on. These energy levels are such that the gap between the first and second is so small that the smallest transition in one series, like for example, Lyman ka smallest transition, the first series is called Lyman. I'll talk about that tomorrow. The smallest transition in Lyman is more energetic, is a bigger transition than the largest transition even in the next series. तो बामर का जो सबसे बड़ा energy gap दिखेगा, that will be between infinity and 2. That is still smaller than that between 2 and 1. In fact, what is the ratio? ये energy difference है 0 और 3.4 के बीच में. ये energy difference है 3.4 और 13.6 के बीच में. तो Lyman का smallest line and Balmer का biggest line के बीच में ratio is 3:1 approximately. Okay, so that's in fact exactly 3:1 का ratio. And that goes on. Balmer का smallest energy transition is still more energetic than Passion का largest energy transition. Okay? So that's one important thing to note. And in the next class, I'll go over these series again. The ones ending on 1 is called Lyman. The ones ending on 2 is called Balmer. Then you have Passion, Bracket, Fund. First 3 are reason. Okay, first 3 yaad kiya to bhi kafi hai, but just general knowledge ke liye, you have Bracket, Fund, and the ones ending on 6 are Humphreys. Okay? Lyman is in the UV region, Balmer in the visible region. Lyman most energetic, UV. फिर Balmer पूरा visible region में. Passion is less energetic than Balmer. It's in the infrared region. Passion, Bracket, Fund, they're all in the IR, infrared region. Okay, कल की क्लास में वापस revise करेंगे. Okay. Anyone has anything to ask, you can ask. I'll upload the lecture as quickly as possible. चलो. Oh yeah, एक second. Sorry. Sir, in Balmer, as energy the difference increases, it can become UV as well. So actually, Balmer is definitely never UV. ये जो बढ़ते रहता है ना एनर्जी डिफरेंस, वो बढ़ के उसका मैक्स डिफरेंस ही 3.4 इलेक्ट्रॉन वोल्ट का गैप आता है. So Balmer is never going to be what do you say, never in the UV region. वो 400 के विद इन आता है. We can do that calculation. Let me just see that. Balmer में if I put N2 Z square को 1 डाल रहा हूँ, Z square को 1 डाल रहा हूँ, N2 को मैं इंफिनिटी डाल देता हूँ, तो ऊपर नीचे कट जाएगा. I'll be left with N1 square. ठीक है, तो N1 square मतलब सेकेंड ऑर्बिट ना, 2 का स्क्वायर, तो 91.15 into 4. Oh yes, 91 into 4. हाँ, that is possible. वो 400 से नीचे जाएगा. You're right, my bad. तो Balmer के most energetic ones could cross 400. You're right. I'll include that. I'll include that in the slide tomorrow. Good. Balmer का जा सकता है. What, as far as I remember, I think the first 4 lines are at least visible. मैं जो draw भी किया ना, first 4 lines they're at least visible. Then 8 point के बाद, yes, they could cross the ultraviolet into the ultraviolet region. चलो, okay. See you. Bye bye.